Okay, so in this lesson we have multiplying, dividing, adding, and subtracting. Our first day will only be multiplying and dividing. So if that's what you want, go ahead and start watching now. If you are missing the second day, which is just adding and subtracting, you might want to forward the video until you see I am talking about these problems or have this paper out, and that's what I'm going to start talking for the second day, right? So, for our first day, this is what we would have done in the past. And remember, on these problems, what we would have done is we would have taken 2 times 5.1 to give us 10.2. And then we would have kept our base, and because it's multiplying, we would have added our exponents. Okay, so remember we were multiplying. I guess I'll show that work. We were doing 2 times 5.1, and then we did keep our base, add our exponent, so it ended up being 10.2 x to the 7th power. Okay, so this was our work, this was our answer before. Today, we're multiplying with scientific notation. Remember, this is in scientific notation because it has a factor, and it is the product of the factor and a power of 10. Okay, so we have scientific notation here, scientific notation here. Because there's no sign in between, that means we are multiplying. You might see a dot or an X in between sometimes too. Okay, so from here, it's the same process. We are going to take our factors and we are going to multiply them. And then before, when we kept our base, this is really like our base today, that times 10 to a power. So we're going to keep our times 10, and then just like before, because we were multiplying, we're going to add those exponents, 3 plus 4. So really, the only new part today is that instead of just having x as the base here, it's going to be times 10. This is not x10, it's times 10. That's how we write our scientific notation. So you would end up with 10.2 times 10 to the 7th power as your answer. So this is what we did before. This is what today's lesson is about. The other one you're going to see is dividing. Previously, when we did this, you would see a problem like this, and you would take the coefficients. Oh, come on. Load in for me. There we go. You would take the coefficients and you would divide them. So you do 4 divided by 2. And then we would keep our base, and because it was division, we would subtract. They're going to end up canceling out each other, so that's taking away that subtraction. So you'd end up having 2x to the 4th power. Today, when we are dividing, it's going to be with scientific notation. So it's going to have a factor, it's going to be the product of the factor and that power of 10. Still going to do the same thing. We would take 4 divided by 2, and then we're going to keep our times 10, and then again, because this was division, we're going to subtract, do the top minus the bottom. This would come out to be 2 times 10 to the 4th power. Okay, so it's very similar to what we were already doing. We're still using those rules for when we were multiplying and when we were dividing, and thinking about the coefficients now as our factors out front. So to show you some examples from the notes, and I do have all of this worked out on Google Classroom as the notes, so make sure you're looking at that PDF if you want to see more examples. Okay, but I'm just going to show you the first two with the steps here. So the first one is multiply or divide the, remember before we called them coefficients, here we're talking about them as factors. So I would take these two, and it says multiplication, so I'm going to multiply. Oop. And then I'm going to keep my base, add my exponents. This is the work that I would expect to see. Okay, So if I multiply those together, and if you want to write them side by side, that's fine. You're just going to see me writing them up and down when we get to adding and subtracting. So that's why I wrote them next to each other. So we would do, and I get 9.8. That was that first step. Second step is that if it's multiplication, we add the exponents. So I add my exponents. And then the last one is make sure it's written in scientific notation. This one is written in scientific notation. If you noticed, this answer was not. Okay, remember the reason it's not in scientific notation is because the factor has to be between 1 and less than 10, at least 1 and less than 10. So this, we would end up having to move the decimal over 1 spot to the left. I always have people say, how do I know which way to move it? Well, if you think about it, if I would have moved it this way, the number would have become 102. That's still not less than 10. So I had to move it over 1 to the left. And the rule that I have been sharing with everybody is that if the factor goes down, the exponent has to go up. If it's the other way around, if this goes up, the exponent has to go down. So what that means, since my factor went down to a smaller number, 10 to 1 is a smaller number, this goes up 1, because we moved it over 1 spot, would be to the 8th power. Okay? This one was already in scientific notation, so we didn't have to change anything on that one. But you do have to check at the end. If it is written in scientific notation, you need to change things. And again, that's if the factor goes up, the exponent goes down, but at the same time as the factor goes down, the exponent goes up. They're always going in opposite direction when you're rewriting them. So this one, first thing we want to do, since it's division, is divide those factors. Then I look at it and I keep that base of times 10. Since this was division, we're going to subtract our exponents. Don't forget, I just did step 1 in green. I thought about multiplying and dividing. Then I did step 2 in purple. If it's division problem, we subtract the exponents. So when I go to do that, 8.1 divided by 3 is 2.7, and it would be times 10 to the 4th power. Okay? Now if it's one like below here, let's see, I know this one. When I multiply these, that 5.01 times 3.4, I know is going to be over 10. So let's see, that would be 5 plus 6. I would end up with 17.034 times 10 to the 11th power. Sorry, you weren't seeing that. I didn't realize it was below the screen. So that's what you would end up with, and this is not in scientific notation. So you'd move it over 1 spot, you get 1.7034. Since this went down from 17 to 1, this goes up, so it would be 10 to the 12th power. Okay, so always be double checking at the end to see if it's in scientific notation. So that is multiplying and dividing in a nutshell. Again, all the rest of this, all of the examples on the back that you can see, those will all be on Google Classroom, so be looking for that so that you can practice some more. The other one, now it is adding and subtracting. Okay, so for adding, when you look at this, you cannot add these together because they are not like terms. Like terms take the same variable with the same exponent. So on this one, it's 1 and it's 2. Those are not the same exponents, so you cannot combine them. Okay. Here, since they have the same variable with the same exponent, we would just add together our coefficients and keep that. That's like saying I have $5 plus $5 more. That would be $10. Okay. on the next one, again, we would just look at the coefficients. Since they have the same variable, have the same exponent, we just look at the coefficients and do whatever they say. 8 minus 6 is 2. And then I'd keep the rest the same. That's kind of the idea for adding and subtracting them. Okay? The key today is that the exponents must be the same. Just like here, we could not add these because the exponents were not the same. So exponents must be the same. Then, once they are the same, remember, we just added our coefficients together and then kept the rest. That's kind of the idea here as well. So I check to see these both have the same exponents. They're the same exponents, we can go to step 2, add or subtract the coefficients. So I'm going to look at this number, and this time it was adding for our problem. So 6.5 plus 3.99, and you could add those together in your head, or I would suggest typing them in just to double check. Even if you do the mental math or work it out through here, I would still type it in just to double check so you're not making a silly mistake. Okay. Once I've done that, adding and subtracting, then it says keep the exponent the same, times 10 to the negative 8th power. That's it. Hopefully you realized on this one that that is not in scientific notation. That's something they did not have on the steps here. You might want to add that in at the end to check to see if it's in scientific notation. If it is not, we just think about the reason it's not is this is over 10. So we have to make it under 10, so I move it to the left to make it smaller. Since this got smaller, this has to get bigger. Now think about a number line. So if this is getting smaller, this has to go up, get bigger. Going up or getting bigger is to the right on a number line. That would be -7 on this one. Okay, always think about a number line when you're thinking about negatives. To the right would be up, to the left would be down. Okay? Now, if the exponents are not the same, like in this one, I have 4 and I have 3, I'm going to tell you to always change it so that the smaller is going to the bigger exponent. So 3 is obviously smaller than 4, so I want to change this to 10 to the 4th power. If I change the exponent, I have to change the factor. Here, my exponent went up. It went from 3 to 4, so this is going to have to go down. To go down, I would move it to the left one spot. That makes it 0.207. Now, when I do this, I kind of cross that out so that I don't accidentally look at these numbers because now I have to use that new number when I'm adding or subtracting. Once you have the exponents the same, add or subtract the coefficients, keep the exponents the same. So when I look at this, I do 7 minus that new number. Again, you can do it by hand, but I'd type it in. And then we keep that exponent, so times 10 to the 4th, because that's that new exponent. Since this one is in scientific notation, we are done. We don't have to change anything at the end. Okay? I also have all of this worked out and all of the back done. You can see those notes on Google Classroom as well. So be looking at both of those things as you are hopefully either reviewing this content or if you were absent, looking at that so that you understand what to do. If you have any questions, make sure you are asking.